Hello friends, myself Rajendra Mahajan presenting my video on how to identify the type of the differential equation and solve. Examples. First one, cos square x into dy by dx plus y is equal to tan x. Second, x square y minus 2xy square dx plus x cube by 3 minus 2x square y into dy equal to 0. Third, x plus y minus 2 into dx plus x plus y minus 4 into dy equals to 0. And the last, then to identify the type of that differential equation, whether it is exact type or linear type, linear in x, linear in y, and fourth one, a reducible to linear form. Therefore, nowhere in the question paper its type is mentioned. We have to identify it, and how to identify that I will explain in this video with the help of these 4 examples. Therefore, watch the video up to end, though it is somewhat lengthy. Watch up to end for better understanding, clear understanding. We know that every equation we can write in the form of m into dx plus n into dy equals to 0, and if the partial derivative of m with respect to y, dou m by dou y, and partial derivative of n with respect to x, dou n by dou x, are equal, then that equation is said to be exact. This is the working criteria to check whether the equation is exact or not. This is not the definition. Definition is somewhat different. If it is not exact, means if that values are not equal, means equation is not exact, means we have to go for the next method, and that is we have to check whether the equation is linear in y or linear in x. For linear in y, general form of that differential equation is dy by dx plus capital P into y, and that is equals to q, where that capital P and capital Q are functions of x or constant. And after deciding that it is linear in y, then next step we have to obtain the value of integrating factor or multiplying factor. That is called as IF, and it is obtained by e raised to integration of p with respect to x. Integrate that term of p with respect to x. This is the important step. Or sometimes we have, if the equation is linear in x, linear in variable x, whose general form is dx by dy plus p into x is equals to q capital, where that capital P and capital Q are functions of y or constant. Then the particular IF, it is not PI, it is IF, make the correction, integration of e raised to integration of p with respect to y. Then third case, if equation is not exact, also not linear, then in that case we have to go for the next method, and that next method or next check is whether the equation is reducible to linear form. We have to check whether it is in that equation reducible to linear form. Sometimes it is also called as Bernoulli's equation, whose general form is like this. dy by dx plus p into y is equals to capital Q into y raised to n, where y is a dependent variable, or we have dx by dy plus p into x is equals to q into x raised to n. Then we try to solve this given example. Number 1, cos square x into dy by dx plus y is equal to tan x. Here we don't know the type of the equation, we have to identify it. Therefore, I will start with that check of exact, whether equation is exact or not. Therefore, we have to rewrite that equation in the form of m dx plus n dy equals to 0 by rewriting that equation. Therefore, comparing with m dx, we get m dx plus n dy equals to 0, we get the value of m as tan x minus y, coefficient of dx, and dy coefficient is n is equal to minus cos square x. Differentiating m partially with respect to y, we get its derivative as minus 1, and differentiation of n with respect to x, minus 2 cos x, chain rule, derivative of cos is minus sin. And therefore, if we observe that two values are not equal, dou m by dou y is not equals to dou n by dou x, means equation is not exact. Equation is not exact, and as it is not exact, we have to check whether it is linear in y or linear in x. If we see the degree of y is 1 and degree of dy by dx is also 1, means it may be a linear in y. And therefore, converting it that general form, dividing by cos square x throughout, we get dy by dx plus 1 by cos square x into y is equal to tan x divided by cos square x. Nothing but dy by dx, 1 by cos means secant square x into y is equal to tan x into secant square x, and we call this equation 1. And then comparing it with the general form dy by dx plus py equals to q, we get the p as the coefficient of y. For this particular example, it is secant square x, and q value on the right hand side, it is tan x into secant square x. After finding p and q, next step we have to find the integrating factor, e raised to integration of p with respect to x, integration of secant square x e raised to, it is e raised to integration of secant square is tan, therefore that if is e raised to tan x. And after obtaining this integrating factor, next step is we have to find the solution by this formula. Dependent variable into integrating factor is equals to a plus integration of q into if, and then substituting the values. For this, dependent variable is y, if is e raised to tan x, a plus integration of q, it is tan x into secant square x into if e raised to tan x. A product of three terms of x integration is not possible. Therefore, we use the substitution technique, put tan x as some t, differentiating it with respect to x, we get secant square x into dx as dt. Put it in equation 2, equation 2 becomes Left hand side remains as it is. Y into e raised to tan x as it is, no change. A plus integration of tan x is t, secant square x dx is dt, and e raised to tan x becomes e raised to t. Therefore, it is a product of two terms of t. Therefore, integrated by generalized part. T algebraic first term, e raised to t second term. Exponential must be second. Therefore, first term as it is, integration of second is e raised to t minus derivative of t with respect to t is 1, and next integration of e raised to t is e raised to t. Taking e raised to t common, we get t minus 1 as a remaining term plus a. Substituting the value of t on right hand side, we get e raised to tan x multiplied by tan x minus 1 plus constant of integration a. Then dividing throughout by e raised to tan x, we get y is equal to a divided by, means when you transfer it becomes e raised to minus tan x. Second term, e raised to tan x get cancelled. We have tan x minus 1 only, and this is the required answer. In second problem, the value of m is x square y minus 2xy square. Derivative of m with respect to y is x square minus 4x square, and n is x cube by 3 minus 2yx square. Derivative of n with respect to x is x square minus 4xy. Both are equal, and therefore it is exact. Then we find integration of m with respect to x. It is y constant. Integration of x square is x cube by 3 minus 2y square constant term. Integration of x is x square by 2. Equation number 1. Then terms in n that are free from x. Therefore, here there is no any term which is free from x. Both term containing term of x, and therefore its integration is 0. Equation number 2. And therefore the solution is equation 1 plus equation 2, and that is equals to constant c. And therefore we have the solution as y x cube by 3 minus x square y square is equals to constant c as the required answer for problem number 2. Then third problem, solve x plus y minus 2 into dx plus x plus y minus 4 into dy equals to 0. It is in the form of m dx plus n dy equals to 0. Always we start with this check. Therefore the m coefficient of dx is here, x plus y minus 2. Differentiating it with respect to y, we get derivative as 1. N is the coefficient of dy, x plus y minus 4, and differentiation of that with respect to x is also 1, and therefore values are equal. Dou m by dou y is equals to dou n by dou x, means equation is exact. Therefore second equation is exact differential equation. Then to find the solution, in first step we have to integrate m with respect to x. Here m is x plus y minus 2 and its integration with respect to x. Integrating each term with respect to x, we get x square by 2 first. Second, y constant outside. Integration of dx is x, therefore xy, and minus 2x. Equation number 1. Then terms in n which are free from x. That term we have to integrate with respect to y. Is there any term which is free from x in n? Yes, there are two terms, y and 4. Therefore y minus 4 and its integration with respect to y is y square by 2 minus 4 into y. Equation number 2. Then solution is sum of these two and equate it to c. And therefore for this particular example, that solution is x square by 2 plus xy minus 2x plus y square by 2 minus 4y, and that is equals to C as the required answer. Then last example, solve x dy by dx plus is equal to y plus x into 1 plus log x multiplied by y cube, converting in the form of mdx plus ndy by rearranging it like this. Then compare with mdx plus ndy. Here the value of m is, this one is m and this one is n. Therefore, differentiating m partially with respect to y, keeping x constant. Derivative of y is 1 and derivative of the second term is 3y square multiplied by that constant term as it is, x into 1 plus log x. And differentiation of n with respect to x is minus 1. These two are not equal. Means dou m by dou y is not equals to dou n by dou x. Means equation is not exact, though we are able to write in the form of m dx plus n dy equals to 0. Then we have to check whether it is linear in y, but there is a term of y cube, and due to this it is not linear in y. Then we check whether it is linear in x due to the term of log x. Equation is also not linear in x also. Means equation is neither exact nor linear. Means we have to go for the next method, and that next method is reducible to linear. Reducible to linear, a Bernoulli's form, whose general form is like this: then dividing by x into y square y cube. Throughout that equation we have 1 by y cube into dy by dx equals to y upon xy cube plus 1 plus log x rewriting it, transferring y cube to numerator, which becomes y raised to minus 3 into dy by dx. Then transferring that term of y to left, it becomes 1 by x into y raised to minus 2 is equal to 1 plus log x, and we call this as equation 2. And then we have to substitute y raised to minus 2 as some new variable z, dependent variable z. Differentiating it with respect to x, we get minus 2 into y raised to minus 3 dy by dx is equal to dz by dx. Therefore, finding the value of y raised to minus 3 into dy by dx is equal to dz by dx. Then y raised to minus 3 into dy by dx as minus 1 by 2 dz by dx. Then substituting that in equation 2, we get minus 1 by 2 dz by dx minus 1 by x into z is equals to 1 plus log x. Then multiplying by minus 2, we get dz by dx plus 2 by x into z is equals to minus 2 into 1 plus log x. Equation 3 is linear in z. Therefore, p is 2 by x, q is minus 2 into 1 plus log x. Integrating factor is e raised to integration of 2 by x dx. It is x square, and therefore the solution is dependent variable into integrating factor is equals to constant a plus q into if and its integration with respect to x. A dependent variable here z, if is x square is equal to constant a plus integration of x square into 1 plus log x and its integration with respect to x. Multiplying by x square inside, we get into minus 2. Therefore, we can take minus 2 outside the integral sign. A minus 2 times integration of x square. Integration of x square is x cube by 3. And then second term is integration of x square into log x. Product of two terms, therefore integrating it by first term is log x. Integration of second is x cube by 3. Then minus a minus 2 times x cube by 3 as it is. Here first term is log x that we write in bracket and integration of second. Therefore, log x integration of x square is x cube by 3 minus integration of derivative of the first. Derivative of log x is 1 by x into integration of second is x cube by 3 and then its integration with respect to x, bracket close, and rewriting it once again. A as it is minus 2 times x cube by 3 also as it is, then plus that x cube by 3 into log x as it is, x cube by 3 into log x as it is, and minus integration of x square by 3 with respect to x. Therefore, integrating that term with respect to x, other term as it is, no change. Therefore, a as it is minus 2 x cube by 3, we can take common from that two terms. Therefore, remaining terms are 1 plus log x minus 1 by 3 constant term outside and integration of x square is x cube by 3, bracket close. From these two terms we can take x cube by 3 common. Therefore, it is a minus 2 times x cube by 3 multiplied by remaining terms are 1 plus log x and minus 1 by 3. And then adding the constant term in next step, we get 3 minus 1, that is 2 by 3. And therefore, final answer is A. Therefore, once again writing that step, it is A minus 2 by 3 into x cube, no change, and 1 minus 1 by 3 is 2 by 3 plus log x remaining term as the required answer. Substituting the value of z as y raised to minus 2 into x square on the left hand side and right hand side as it is. Please like my video, share it, as well as subscribe to my channel, and to receive the notification please press the bell icon. Thank you. Thanks for watching.